All right, good afternoon. There's a saying that goes that you can give a man a fish and he can eat for a day. But if you teach a man to fish, he can eat for life. In an hour, we don't really have time to teach you how to fish, but what we're going to do is show you where the fish are, or show you the features that are for performance and debugging for native developers. And then you can use Google, our documentation, the Ask the Expert sessions, and the labs that are coming up this week to help yourself learn the specific areas that you're interested in. So today's going to be a bit of an overview of all the great features we have in the native SDK for debugging and performance. I'm David Cummings, and I'm here with Elena Laskavaia, and we're part of the tools team at QNX who work on the native SDK. So first off, why do you want to debug and optimize performance? Well, debugging is a fairly straightforward concept for developers. It helps you speed up your development time and helps you track down bugs. But why would you want to optimize for performance? Well, it really comes down to what Alec was saying this morning in today's keynote. You want to make money. And the key to making money is having a great app that people like. So I have two examples of reviews on App World here. So the first one says that the app graphics are fluid and smooth. It's great integration with camera and GPS. I'd recommend it to everyone. It's got 5 stars. Whereas the next one, it took forever to load. After a few minutes of usage, the app crashed. I wasted $5, and it's only got a single star. So as a user, you'd obviously probably gravitate towards the application with the 5-star review. And as a dev, you're looking to get those reviews. And Alec was saying today that 50% of the revenue out of App World comes with apps that are rated 4-star or better. And to get those great ratings, you need to provide a really good user experience that performs well, that's smooth, and that acts like the other apps that are shipping on the platform. The other reason you may want to optimize is for the Built for BlackBerry program. So we're launching the 10K Developer Challenge, which gives you the ability to get a certification built for BlackBerry and guarantee your revenue of at least $10,000 in the first year. As part of that, there's a set of criteria that your application must follow, and some of them are surrounding performance. So the keys there is that your memory, you can't consume more than 30 megabytes. Your launch time must be less than a second. You need to ensure that you don't have any UI lag. So that means your application is running at a full 60 frames per second. And there's also a few requirements around battery drain. So when your app is backgrounded, you only consume a certain amount of power. And same when you're foregrounded or doing a lot of animation. So first, I'm going to cover some topics about debugging, setting it up using the IDE. I'm going to go into debuggers and our logging frameworks. And then Elena's going to talk to you about some of the things about performance. So speed, memory usage, battery usage, disk usage, the bar file size. And then if we have some time at the end, she'll talk about some great APIs that we have that will allow you to write your own performance tools or analyze your code programmatically. So the native SDK ships with the Momentix IDE. Familiar with IDEs, it basically allows you to compile, package, deploy, and upload your code all in one easy step. It also has a full command line tools that you can do all those steps manually, but the IDE sets that up to do it a lot easier. In the IDE itself, we have a standard launch, which is what you would expect. It compiles packages and deploys the application onto the device itself and hooks up the debugger so you can step through code. We have some additional launch configurations to allow you to transfer files to the device and from the device, perhaps when your application finishes, to download some log files. And a group launch configuration that allows you to combine those all together. From the command line side, we have BlackBerry Deploy, which you can use to deploy your applications to the device. We also have a BlackBerry Connect, which gives you an SSH connection to the device so that you can use tools you may already be familiar with, including SCP and SFTP. So I'll move on to debugging and logging. We provide a bunch of different debugging options in the Momentix IDE. The normal one being standard debugging, where your application launches, a debugger gets hooked up to it. It optionally stops on main, but you can set up breakpoints, inspect variables, step through your code. Some of the more advanced debuggers that we provide is attaching to a running application. So if you already have an app running on the device where the debugger is not attached, you can do so. There's Postmortem Debugging, which gives you the ability to debug an application that's crashed. I'll go into that in a little bit more detail. We also have the ability to debug native extensions. So if you're using native extensions in your Air application, you can debug the C code for that. And finally, new in beta 3, we have the ability to debug your JavaScript code in your QML. So if you're doing any Cascades work and you're having some issues with your UI logic, or if you're doing any business logic in your QML JavaScript, you can debug through that as well. One of the keys to remember when you're debugging, this is really imperative, is that the debugger won't work if your platform version doesn't match between the NDK that you're using and the device you're using. The IDE does have the functionality that it will warn you when these do mismatch and inform you on how to proceed. But if you're doing command line, you really need to make sure that, that these match. So in the About screen under the settings, the OS version is listed there. And in the NDK itself, you can see which version of the NDK or SDK you're building against using the toolbar at the top. These version numbers may differ by about 1 or 2 revisions. So typically the OS version, let's say, would be 235, and this would be 237. If you're using the command line, the suffix on the target folder gives you an indication of which version you're using. New in the new beta 3 release, this toolbar is actually new, and it basically allows you to quickly toggle between different NDKs and rebuild against them. But we have the ability also to do that on a per project basis. So if you're still doing a bunch of Playbook 2.0 development, for example, you can have some of your projects set up to build against the 2.0 NDK and some of your projects to build against the latest BlackBerry 10 native SDK. The attach to running app launch configuration, as I mentioned, basically allows you to attach to an application that was already running on the device. Say another developer on your team was running something and ran into a scenario that you hadn't seen before, and you hadn't launched with the debugger already. You can use this launch configuration, simply specify the project that you're using and the device you want to connect to, and press launch. That'll hook up the debugger, show you all the stack information, and stop. And then you can proceed to debug just as you would have had you launched with the debugger attached. Postmortem debugging, when your application crashes, it generates a core file which contains information about the application state when it died. And that includes the stack information, local variables, global variables, and such. And that file gets generated in your application sandbox in the log directory. So if you use the target file system navigator in the IDE, and navigate to your sandbox and then your application name, in the log file you'll see this core file, and that's what contains that information. If you drag and drop that into the IDE and then use a postmortem debugging launch configuration, you can select that core file and press launch. What that'll do is it'll bring up the debugger in that exact state, so it'll show you exactly what stack the threads were in. The code will be selected to that area. And the variables view will show you any local or global variables that were applicable. Now, obviously, because it's postmortem debugging, you won't be able to step through the code, but it should give you an indication of perhaps where that problem occurred. As I mentioned in beta 3, we now have the support for JavaScript debugging. It gives you a typical debugger that you'd expect, so being able to set breakpoints, step through code, and inspect variables. To set this up, basically all you need to do is enable this preference and add some specific user code to your main.cpp for your application, and then launch as you normally would your Cascades app. And what that will do is it'll, anytime you have a breakpoint set in your JavaScript and the application steps over it, it will stop. This specific code is the code that you have to add into your application. All the code that you'll see in the presentation today will be posted on the on-demand portal. So don't worry about taking pictures and such. You'll be able to grab those later. And here's an example of that JavaScript debugger. So it's basically showing we've stopped in this QML file. We can see exactly where we are in this onTouch method and the value of any of the variables. Logging is another debugging method that people use. I mean, the quick and dirty way is to use printf. One key to remember when you're doing that is to remove all this code before you ship your production version. So when doing printfs, it gets logged to the log file within your application sandbox, which means it's stored on disk, which means it will slow down your app and it wears out the flash. So we do in beta 3 have this new slog2 API, which allows you to do in-memory logging. I'll talk about that a little bit. So it's low overhead logging in memory with the ability for you to be able to inspect that and write it to disk if you so choose. The QDebug and console.log framework and Cascades have all moved to that slog2. So if you're doing printfs or using QDebug and console.log in your Cascades application, it will no longer show up in the log file of your app. It will go to the slog2. So in order to see that information, you need to run the slog2 command on the device to see that log. In order to set up slog2 usage, there's a simple init method that you need to write basically to set up the buffers. And then you log messages using slog2c with a specific code and indicating the severity of the slog message and then the message that you want to log. Here's an example of slog2 initialization. The key to remember here is that if you're doing a Cascades app, the Cascades application will do this for you. But if you're doing a pure native C or C++ application or a pure Qt application, you'll need to set this up yourself. There's some great API documentation on that, but this code sample, again, will be provided. Forthcoming in the Gold release, we will have a log in the native SDK in Momentix to be able to see this information. But for now, what you can do is in the target navigator, right-click on your device and choose Launch SSH Session, and then run the slog2 info command on the terminal. And that will output all of the log messages that were generated. You can also run it with -W, which is streaming mode, so that any new messages that get logged will show up automatically. One thing that sometimes developers struggle with is troubleshooting user issues once they've already released their application. So the slog2 API actually sort of helps with that, in the fact that you can, there's an easy logging method for release mode applications. And what we're recommending is that applications provide sort of a send bug functionality in their application, which then takes the slog2 info and sends it to them in the event that the user has a complaint about the application or such. You can do that. So the actual log file is located in this location. So you'd want to include that in your bug report. And if you are including those in your bug report, in order to view them, you'd use the slog2 info command with the -L option. It's also important to include device-relevant information. So in things like the OS version or the version of your application where the bug happened, so that it makes it easier for you to track those issues. So I'm going to pass it over to Elena, who's going to cover some topics about performance.
So a few performance areas we're going to talk about is CPU utilization, memory usage, battery usage, disk usage, and optimization of a bar file size. And later I'm going to talk about some of the APIs you can use to access some of the tooling. So roughly there's a few optimization you can do for CPU. There's startup time. It's a time between user click on the application and user sees some sort of reasonable screen and they can start working with the application. There's UI lag. It's when your application, if for example you scroll it and it stutters, or user click a button, it will take a lot of time to show up next screen. It's UI lag you're trying to optimize to make it smooth and fluid. Frame rate is how many frames per second your application draw. And in general performance, if you just like long-running operations, some disk access or network access, and when user have to wait, you can try to optimize these things too. So for startup profiling, it's good if you can start your application in 1 second. So tools currently we have for that, we have a slog2 info that David mentioned before. And when you use Cascades application, Cascades framework going to generate some events automatically in this log. And you can inspect this log to find out events marked startup. So every event on the log is marked with timestamp, and its resolution is milliseconds. So you can see in this little example here that there's time between Cascade server thread starts and user see first screen was about like 4 seconds. So it's pretty long time, so you can try to optimize it. As well as for non-Cascades application, you can inject your own events. For example, I can, just at the beginning of my main function, I can put event like main start, and when we start rendering, I can put event start rendering. You can measure that time and try to optimize that. There's also lots of time that your application might spend before entering main. What happened there is operating system trying to load your executable from disk to memory, as well as all shared library it contains, and trying to dynamically link shared libraries. There's a few ways how you can optimize it as well. And you can do it without any coding by just inserting some compiler flags and changing your make files to create beta executables. So a few things I want to mention here. There's compiler flags to reduce amount of symbol tables that you have in your binary. There's a set of compiler flags you can do to reduce size of code that compiler generates. As well as if you have your own libraries you're developing for componentization purposes, you always want to link them statically. And kind of opposite, if you want to use library on device, you always want to link it dynamically. A few tips for improving startup time for Cascades app. If you have a QML of the first screen, try to put it as try to make it as small as possible, because if you put in lots of information on that screen, lots of tabs, and some other things which are not needed on the first launch, they're going to slow down the startup. So make it as small as possible, and they can load other pages asynchronously. Also, don't put any time-consuming stuff on the C++ constructors. If you put, let's say, database loading in your application constructor, that means all the connection to database, everything else would happen before even your application starts rendering, meaning your user is going to just see the blank screen or splash screen while you're doing all of this. So instead, you try to load UI as soon as possible and then do all the database access and everything else asynchronously. Don't do any data loading in UI thread again, because that would manifest itself in UI lag. So you want to make sure you're not doing anything heavy in the UI thread. Another thing, if you have list items, you have, let's say, list with checkboxes, list without checkboxes, list with something else. People tend to try to create one list and have this item which have different visibility rules and so on, but it makes it very slow. So it's better to have multiple lists with different items than one list with kind of gigantic list item with visibility rules on top of it. So keep list items simple. And as last resort, if nothing helps, if your performance is still bad, you can try to use C++ instead of QML. There's a few tips about asset optimization, and this is regarding graphical assets. So the kind of obvious one, if you have an asset which only has like one color or gradient color, don't use it, use background color. It seems obvious, but there's a lot of people who would use that and would load huge textures, which is just one color. If you have little image in the middle and there's a bunch of transparent pixels surrounding, again, cut the transparent pixels out, just package a small image and offset it. Same thing for if you have image representing just the border, use technique called 9 slicing, which allows you to package very small image and use 9 slicing to scale it properly to represent border. Use, again, tiling to represent tiling to repeat a texture. And if you need to show small icons, don't try to scale it down, but rather pack a small icon. There is also some authoring tools like Photoshop. They can add a lot of metadata in your files which you're not even aware of. So before packaging these files, try to use some utilities which compress it or strip down unnecessary meta info. As well as when you load in assets, do not try to load them all at the same time. For example, if you have an application that shows album covers, it's not necessary for user to see them all at the same time. It's probably good enough if you just show the name of the album and then load them asynchronously, and then when they're ready, you can display the actual image. For UI lag and frame rate, again, Cascades framework going to inject logging events in slog 2, and it has some performance statistics about how many frames was drawn, how many frames was dropped, and you can use some of this information for optimizations. And the goal frame rate is 60 frames per second. So for general, if you want to go deeper into the profiling, we have a few tools. And one of them is system summary, just show you overall performance and how much CPU your application process using. And a profession profiler allows you to go deeper and actually see for each function how much time it took. So system summary in IDE looks approximately like this. It's just going to show you CPU usage in milliseconds of your process. And if you click a little button that shows you diff, that would show you how much time it spent after you press the button. So application profiler, it's a tool for generic profiling. And it can show you drop-down view of the functions with times. It has a call graph view. And it has a table. You can sort, let's say, top 10 functions that took your time. There's an annotated source file editor. And there's API available for the tool to allow you to scale down how much data you're receiving and to stop profiling certain points. To use it from IDE is very simple. You have to recompile your application in profiling mode. For non-Cascades application right now, we have kind of ready to use build configuration. And for Cascades app, it's coming, but you can manually create a compiling configuration for that. After you compile it, you just say profile as, and you need to enable application profiler tool in the tool selection, and then just run it, and you'll be able to see results. Excuse me. So this is typical view for application profiler. You'll see a call tree stack. And you can kind of see how many percentage it took, so you can expand it and keep digging until you find out something weird going on with your application. And when you find it out, you can double-click on that line. It will open editor. And you can see annotated editor. Annotated editor that shows you for every line how many milliseconds or seconds is spent on that line. So the options you need to use, instrument functions for compiler and link with profiling library. And when you run it, it's affected by environment variables. So to get advantage of this, it's usually going to be a lot of data. So in the first few minutes, it's going to generate gigabytes of data. So you want to manage it a little bit. So you would probably want to instrument not all the code, only suspicious code. And there is other option to exclude some files from instrumentation and so on. As well as the profiling API, qprofiler.h, and that allows you to start and stop profiling. You can use different modes of profiling, different counters, including memory counter instead of CPU. So about memory profiling. So tools we have for memory profiling in IDE, we have two views. One is to show overall memory, that shows different things like stack and static memory and so on. And one specifically for heap that shows you statistics on the heap consumption. You don't need to do anything with your app to see that. You just have to connect your device to your computer, run IDE, it will see the data streaming in live. Of course, you have to have your application running in development mode because you cannot see data from other applications. You only can see it from your applications. Then to dive deeper into the memory, we have memory analysis tool, which allows you to see more details about allocations, and you can find errors as well. Before talking about memory analysis, a little bit about how allocator works. So we have basically two allocators. One is small block allocator, which have pages of fixed size and allocating blocks under 128 bytes. And for bigger blocks, we have an arena allocator where it allocates bigger blocks. So if you're thinking of optimizing your allocator bar, you're writing it, it's probably not a good idea because it probably works already faster than you can do it manually. So a few ideas about how to optimize memory. So first you can find and optimize explicit memory leaks. And this is a concept only for languages which don't have a garbage collection, such as C, C++. So you allocate memory, you don't free it, that's going to be memory leak. So the memory analysis tool can detect these leaks automatically. The second is implicit memory leaks or retained object. So usually what you can do, you can run the application, you can watch the memory grows, for example, using memory information tool. And then that means you allocating memory and not freeing, but it's not necessarily implicit leak. It's just stored somewhere, like in a cache on some other, somewhere else. So again, you can use memory analysis to see what exactly objects are stored in heap at this point. Then you have some advanced techniques. You can try to shorten the life cycle of your allocated memory. And you can try to reload allocations, or you also actually can tune our allocator to specify blocks of memory which your application uses the most. So this is an example of system information view. I selected the process, and I can see now how much stack it takes, how much program it takes, heap, and so on, shared memory, how many libraries are loaded. So usually when you look at your application, you're going to have problem with heap, because that's the most memory which is used by application. So specifically for heap, we have another view that shows memory managed by our allocator. And you can see in details how much free memory you have, how much used memory you have, and overhead. Sorry. And free memory here is the memory that the application freed, but it's not returned yet to the device pool, because it might be used on the pages which are, they only use a small portion of the page. And the bottom is a chart, and if you can execute some scenario of testing, and if this chart shows grown memory, this probably means you have memory leak. So memory analysis tools allow you to do heap memory optimizations, performance improvements, and find memory errors and leaks automatically. It provides charts for memory usage and also show retained objects, and it finds automatically memory leaks. So this is an example of how to find leaks. It's pretty much going to list all the leaks you have, and you can double click on them, see the backtrace where it's found, and see it in source code. So again, usually it's going to be a lot of data that memory analysis have, so it would be hard to navigate in this data. And for that, you again can use API. There is API in our check.malloc.h file, and it allows you to dump memory leaks or to start-stop tracing or memory or error collection and so on. As well as if you don't see backtrace, means it doesn't do good with stack unwinding. You can, instead of, this tool works, you don't have to recompile code to use the tool. But if you do compile it with profiling, it will have better results for stack unwinding. So if you want to optimize for battery, we don't have specific tools for that, but it's directly related, of course, to CPU consumption, to screen usage, and to the usage of peripheral devices. For now, we have a file which is generated in shared directory called standby log, and it's going to analyze how application using CPU while in standby mode. And if you see your process in this log file, means you are offending, so you are doing something wrong and using too much battery. So you probably should pay attention to what you're doing when you're in standby mode. So recommendation would be, of course, to reduce CPU consumption, monitor your CPU consumption, do not do spin locks and trying to spin and do something. Use wait APIs and notification APIs. Reduce communications with sensor, disk, and network if not needed. And do not pull, because what happens all the time is like, oh, I need to have some notification which only happen like once a day, so I'm going to try to pull my server every minute to see a notification. So it's very bad for battery. So instead, try to use push APIs, which we're going to publish, and that means your application doesn't have to run at all, and it's going to be notified and backed up when this notification arrives. We have similar notification mechanism for, let's say, changes in file system on some other events and so on. Again, don't force screen to be alive if you don't need it. The only real application that needs a screen to be alive is a movie player, because people who watch a movie do not touch it. Otherwise, if it has like newsreader and so on, you don't really need to force it, because if user doesn't touch a screen in 5 minutes, he's probably not interested in not reading that article. For disk usage, right now there is no specific recommendation about that, about how much you can use memory, but you have to be, have some sense about how much you can take, as well as it's a very bad idea to generate some files which grow unconditionally. In this example, we can find that some applications generate log files in the shared folder, which is really bad, because you cannot, everything generated shell of folder is not deletable if you uninstall application. So user have to find these files and delete himself. So recommendation for disk consumption would be store all the permanent data for the application itself in data folder. Do not store any private data, private files and shared. Files and shared only for user to consume, irrelevant of your application. Store all temporary files in temp, because this folder automatically cleaned up, so you don't have to worry about too much about cleaning it up. And as well, try to compress store data if it's not in heavy use. The bar file size. Bar file is a BlackBerry application archive. And it's a file that how your application is packaged. So why you want to reduce size of bar file? First, it's app upload time. If it takes like forever to load, people might give up on it. Then it's, if you use over cellular phone, it's a paid data bandwidth. So again, smaller apps will have better chance people would start downloading. The bigger size, also the bigger is going to be startup time. Because we have security on device, secure device is going to do some checks before it starts up. And it's going to check all the checksums and all the assets you have. So the more assets you have, the longer your application will start. And recommendation, again, for to reduce the specific compiler flags, which I mentioned before, which are going to reduce your size of the binary on all the assets. The flags for graphic assets, to use some tools to compress them or get rid of metadata for assets. If you have more than 500 assets, it's not good to put them separately. It's better to zip them in a big file and include that file inside the bar package. Then you can either read them on the fly or you can unzip them on the first use. And if you have heavy assets that depend on language or device, it's better to separate your app in smaller bar files. For example, you have one file for one language and one bar file for another language. This way, you can reduce size of individual files. So if you don't like any of the tools that I show, you can write your own. And this is pretty advanced stuff, but I want to share it with you too. So if you want to inspect how much time certain function take, you can use this API. It's clock cycles kernel call, which gives you highest resolution CPU timer. This resolution is like better than nanoseconds. The only caveat with this, because it's per CPU timer and our devices have 2 CPUs, if your application switch between one CPU to another, your timer would mismatch. So to use this API to measure something, you have to bind your process to certain CPU. And the code on the bottom allows you to bind it to specific CPU, like CPU 1. And the code on top shows you how to obtain this counter and how to kind of print in a meaningful way. And there's a full example that how we use the API to print out how much time certain function takes. Again, if you want to do similar things, but about memory, you want to know how much certain function take memory, you can do it yourself. There's Allocator API, it's a pretty much global variable that keeps all the allocator statistics. As I mentioned before, we have a small block allocator and large block allocator. So there's 2 variables here that keeps, let's say, allocated memory. So you sum in a map, you have how much application allocated memory currently. So if you can print use memory before the call, then you can do your function, and you can print use memory after the call. You will know exactly how much memory this function took. The function instrumentation is a technique that our application profiler used. Basically, it's compiler flag. It's a GCC has this flag. And what to do if you have this flag in your compilation options, it will insert 2 hooks in the beginning and the end of every function. And that would allow you to do like lots of different things, including what we do in application profiler. We measure time before we start function and after we've done this function. And this API will also pass you the address of the function as a parameter. So another very cool thing that you can do, you can intercept any of the system function call. That's how our memory analysis works. So we intercept malloc call, and we do our own instrumentation on that. You can do with anything. You can do it with open. You can do it with any function call. So to do that, there's 2 options. You can use flag environment variable LD preload to preload your library. What means your library is going to be loaded before libc, which has all these function calls, or any other library. And you can execute your own code. Or if you link your statically to your binary, again, it will be all the reference will be resolved first to your library instead of the system one. Once you kind of intercepted the function, you actually probably want to call original one because you still want to call it. So to do that, you use DLSym, which is going to resolve original function. And you can, let's say I do real malloc, and I call real malloc from my malloc, and I can do something else with it. And if you're creating this library that does this, you want to probably initialize your library. And for that, you can either initialize on first use, or you can initialize using this GCC attribute called constructor. If you add this attribute to your function, that's going to be a function that's going to be called when your library is loaded. So all these tools would return your address of the function. So what you do with this address, because you need actual file name or line number or function name, right? So there's API called DLAdder. If you're running it on the device, that would return a symbol that's matching with the address you give it to. The only problem is this API. It only works for function and function table. And these are functions that export it. So static functions or some other functions would not be there. You can force compiler to export all the functions so you can use it. But otherwise, you would see some weird stuff in there. The other method is to use host tool, which you ship as NDK, called other tool line. This tool takes address of the address in the address space of application and the binary, and it would print you file number, file name, and line number. The caveat with this tool is it takes address relative to beginning of the binary. And when you're actually running on device, all the binary and library loaded on certain address segments. So to use this tool, you need to know where your library or binary is actually loaded. And for that, you can hook to dynamic linker. And this LDD register call hooks you to dynamic linker. And dynamic linker will tell you exactly at what address every library or binary is loaded. Then you can use this information together with other tool line to resolve the symbols to function name or file number. Another cool thing is debugger. Debugger pretty much will let you to attach to a process and execute any other function in the process space. So you can create a lot of cool scripts using this technique. For example, you can attach to your currently running process, you can insert breakpoint, and you can, let's say, print value of some global variable. You can execute any function. All this stuff going to be output at the log, and then you resume. And that you just write a script that would do all of this. It'll give you data collected from your application running. Then you can write some other tool to extract all this information and analyze. So you can trend your, I don't know, data usage or some other points that you can come up with using this debugger scripting technique. So as a summary, the tools we provide from IDE is we have system information that gives you streaming information from device. We have application profiler to dig deeper into the profiling of application. Memory analysis to optimize your memory. C++ debugger and JavaScript debugger help with debugging. All this stuff available from command line tools. And the APIs we have login API, the different counters API, which I mentioned for CPU and for memory usage, as well as you can use function instrumentation, override functions, together with address translation to give you very cool tools, and debugging scripting. So for more information, if you're interested in trying all these tools yourself, Tomorrow, we're going to be running optimization performance lab. As well as you have your own application already, you can come to the lab and we'll help you to optimize your existing application. And if you're interested in build for BlackBerry program, which is talking about certification and what criteria your app has to met to be certified and to be
Build for BlackBerry?
Yeah. Build for BlackBerry, you come to this session. If you need information about native SDK documentation, you can go to this link. Me and David are going to be available on one-on-one sessions. If you have any questions for us, you can come and sign up for a one-on-one 50 minutes talk at the Hall 1. And tomorrow, I'll be there at 1 p.m. and at 6 p.m. for an hour, and David at 1 p.m. and 2 p.m.
The other thing, oh, sorry.
So we also have a roundtable today at 6 to discuss this session, if you want to come to discuss it in more details. And if you want to do Twitters, and you can use BB Jam tag and Jam 10 tags. And don't forget, today is going to be party at 7. So you can come and talk to me and David there as well. And yeah, give us your reasons to believe. At the 10K reasons to believe in believe booth in the Jam space. And if you have any questions right now, we'll take them.
So the question is, are there any tips or tricks for monitoring network utilization?
There's a program called NetStat. I believe it's available on the device if you connect to it. Otherwise, we didn't come up with any specific tooling yet.
But if you have specific requirements, feel free to come at 6 p.m. because we're always looking for ways that our developers are looking for new features. So. Go ahead.
Okay, the question was if there's any way to find information about crashing on the devices. There is no specific framework that we have right now to do that. You can do it yourself. You can intercept a signal. When an application crashes, it's going to send certain signals. You can add to this hook, and you can probably call some code that send you a message that the application crashed yourself. But we don't have a framework or any automated way of doing this. Yes, if it crashes, you cannot retrieve these logs. And again, this new API that you should be using, it's unless you do it yourself, nobody else can do it. But when applications start up, you can actually read these logs again and send them.
So will they maintain this time? Because normally when it crashes, it cleans out its space also.
The original one, when you do printf and stuff, it would go to like log directory, a log file in your sandbox. That's cleaned. But the log files, which are created by Slogger APIs, log2, they're not cleaned. They're going to stay there. They're just kind of rotating buffers. So when you reach the buffer limit, it's going to override it. So continue rotating.
The size limit is on
The buffers for logging? You can specify it yourself, and you can create multiple buffers. I'm not. Yeah, initialization calls specify how much of the buffer you have, and you can have different buffers for different logging. You can have like one for errors, one for debug information. They have different sizes and so on. It's like very powerful like API to specify what you need for this logging stuff.
And that's a ramness, so it's not going to survive a reboot, right?
Correct. Yes.
So that's The question was, if you swipe from the top right corner, you see some overlay of performance statistics.
Yeah.
So I don't know if that's actually specifically coming from Slog.
No, it's not Slog. It's just a different tool that just running performance statistics.
The question was, do we have any profiling tools specifically for OpenGL?
Not that I recall.
Nothing specific, no.
I know there's some vendors that are doing specific things for like GPU stuff, right? Yeah, we don't ship it, but if you find something, it might work.
Yeah, one of the slides show a whole bunch of flags to use for release builds. Are they the default or not?
They are not default right now. We're trying to make them default, but yeah, right now you. If you download the slide and you kind of Google what it means, yeah, we will try to, by gold release, try to make sure that all these flags, including security flags as well, are enabled by default for release mode. But right now, they are not.
So if I'm using export or release build or whatever, I have to first go into the configuration and set up this one.
That's
Yeah,
correct.
for now, yes. Mm-hmm. No, it's ongoing. It's going to be in certain intervals. It's going to output the statistics.
Well, thanks very much for the questions and attending the sessions. And again, if you have questions, we'll be available at 6 p.m. in the main hall today, and we have a bunch of one-on-ones as well. So we encourage you, if you want some of our time, to sign up for those.
Thank you very much.